right, let's see. So I only recently joined NVIDIA around 2 months ago. So I'm going to use that time to go over some of the things I've been doing over the past 10 years and use these events to kind of inform us on how I think things are shaping up. So when I talk about AI, I like defining AI as giving us humans superpowers. And what I mean by that is I really think that AI today is about empowering us to do things better, faster, as opposed to replacing us. And so some concrete examples of what I mean by that is the way we're currently leveraging this new wave of algorithms is to do things like helping doctors make better diagnoses, helping people in their daily lives, assisting them in doing things in a better way, helping creators explore more ideas, compose music, video games. And when you think of AI like this, I think it's a really empowering way of thinking of our work. So a couple of things on myself. Over the past 10 years, I've been obsessed with basically 2 or 3 things. The main one is about reproducing human perception. This has been a guiding principle for me over the past 10 years. I'm obsessed by what it means, and what it can enable. The second thing is having the ability to do this fast enough that it can actually be useful. It's one thing to reproduce some of our capabilities. It's another thing to actually do it fast enough that you can actually use it to interact with complex environments and do interesting things. And the last thing is really kind of like building these things in a way that is really going to be empowering every single industry and making all these tools that we're building broadly available. So this whole recent revolution in AI and particularly computer vision really started with this magic algorithm from the 80s. So Yann LeCun was working on that in the late 80s, early 90s. It's called the Deep Convolutional Neural Network. And I discovered that algorithm around 10 years ago. And to me, it was really a moment where I suddenly realized the types of things we were going to be able to build. And so a few years later, I started working on this really, really cool project. And this consumed quite a few years of my life. I did my PhD thesis on this. What we're showing here is basically a system back in 2011 which had the ability to take a 360 video feed and basically process it in real time and essentially segment and classify every region of the visual field. The amazing thing is that back in 2011, the compute power we had to do those types of things was actually really limited. So we also developed dedicated hardware to actually speed up these things and actually make them real time so that we could use them to navigate robots, for instance. So fast forward a few years, what ended up happening is that in 2011, 12, 13, this dream of building real-time perception actually became reality. And it became reality for a few reasons. The first one is that compute power was finally like exactly what we needed to actually train those things at scale and start building things that were really interesting. The second thing is that we came up with a few interesting tricks and simplifications of this core algorithm that actually made it possible to do these things in a more robust way and more repeatable way. And so what happened is that timescales started to change. It took me months, 6 months, 9 months to actually produce the video you saw before, like starting from raw data, labeling it, and then going through this experimental cycle of refining the algorithm and actually getting it to work. Incredibly complicated, Fast forward a few years, anybody can now do that in a matter of hours with tools that have been commoditized and are basically available to all of us. So at that time, around 11, 12, I got really excited by the idea of starting a company that would leverage this tech and actually start creating some value, basically. And so what we did is we started this company called MADBITS, and we focused on this core idea of what if we could look at all the data that a user generates on the web, Instagram, Twitter, it's his own personal device, personal photos, and so on, and basically map all these things into a space where we could run very high-level queries like show me all my photos that I took in New York last year that are about food, you know. And so we built an app, we built an endpoint that could basically help us do a lot of these things. The service was really cool. We sold it to Twitter. And at Twitter, we started generalizing this core technology to do all sorts of other things. And Manohar actually gave an amazing presentation of what's happening at Facebook. Some of these things were also happening at Twitter. And basically, we ended up building the core infrastructure for deep learning to process everything from tweets, images, videos, streaming live video, and then integrating things like sparse features, graph features, so that we could really build very rich representations of everything that basically concerns the user, and from that, predict what the user was going to do on the platform. So this was really exciting. And by the way, are any of you watching the HBO show Silicon Valley? All right, cool. Yeah, so in one of the last episodes, there's this dude, Jin Yang, who comes up with an app, and he's basically literally involving a full Stanford class to actually label training data for him. And he ends up building this app that classifies videos in a way that's a bit simplistic, but apparently he ends up selling the app to Periscope, Twitter, because it does better than whatever Twitter is doing. So I was a bit humiliated by that, but it really shows that this tech is now such a commodity that even Jin Yang can do it, you know. So all along, you know, while we were doing that, what powered us through this whole revolution was GPUs. And back in 2010, you know, what was amazing is that when we built these first demos, the compute power we had on one GPU was around 1 teraflop. And the tools we had were not that great, you know, so we could not even really like completely exploit that compute power. Fast forward 7 years, just 7 years. 3 weeks ago, we announced a new generation of GPU that now gives us 120 teraflops. That's 2 orders of magnitude improvement over 7 years. That's something like 5x Moore's law. So we're literally kind of like transcending Moore's law by a factor of 5. And the reason that's happening is that the chips and the architectures are specializing in a way that's really making, you know, taking advantage of what deep learning is about. And that is really what's enabling us to do so much more than what we could do at the time. So at NVIDIA, because NVIDIA has been powering this whole revolution for the past 7-8 years, you know, the company is now strategically investing in a whole bunch of areas that we believe are going to be instrumental for so many industries. And this is a snapshot of them. So from healthcare to self-driving cars, simulating AIs in virtual world, and then bridging this virtual world back to the reality of things like smart cities, where this portfolio of applications, which each have unique requirements, but they all share this kind of like same core fundamental algorithm. They all rely on that good old deep convolutional networks. And I'm excited to be at NVIDIA now because I really believe in the fact that deep learning is now becoming part of our software stack. It's not this kind of like crazy algorithm anymore. It's really becoming this commodity module that I think everybody is going to end up using. And so I want to make that part of our day-to-day software stack. In terms of next steps, as I said, I really believe that, you know, deep learning is becoming an integral part of our workflows. Every industries are going to become, you know, impacted by it. And I think one of the most exciting things that we're noticing now is the fact that perception is basically helping us bridge back, you know, these virtual worlds and the real world, and that's really something that's amazing. So that's all I have to say, and I'd love for you to go watch this video. It's the video that we used to open our keynote at GTC a couple of weeks ago. The video basically shows you what AI can do today. And it's really about helping people do more. And I think the video is phenomenal because it looks like science fiction, and the reality is that every single bit of it is actually real. So thank you.